Hello, everybody. Today we're going to be discussing ventilation in commercial buildings and schools. It's something that I've been working on for a few years. I kind of grew an obsession with ventilation a couple years ago uh, when I read an article from Berkeley Labs on ventilation in schools, and it kind of resonated with the experiences I was having with poor ventilation in schools. So some of the work that I've done in the past 2 years on ventilation is now very useful in helping reduce transmission rates with COVID-19. Okay, why is this not working now? Okay, here we go. So my name is Roger Silveira. I'm the Director of Facilities and Maintenance for East Side Union High School District. Um, East Side has roughly 2.6 million square feet um, of buildings that I manage under a roof. We span a territory of about 20 miles between campuses. Our furthest campus is 20 miles from one another. Um, and we manage about 500 acres of land altogether. So we have a really large portfolio, and we service roughly 24,000 students and about another 1,500 teachers of the space that we manage. So some of the goals for today's meeting are kind of an overview of guidance on ventilation and air filtration systems, and the role preventative measures such as wearing masks play in reducing transmission rates, how outdoor air exchangers are critical in reducing transmission rates, and how they work in buildings, kind of understanding what upgrades we can do to HVAC systems to help combat and reduce transmission rates, and then a few scenarios that we put together on some of the three most common situations that come up in questions when dealing with ventilation in offices and buildings. So a little background, a little bit of history on ventilation. Ventilation is something that's not new to us. The study of air quality dates back to the 1600s, so it's something that's been talked about for many years, and it just kind of seems to have been forgotten. But it's not a new subject, and even in the even in the late 1800s, CO2 concentrations were closely related to air quality and looked at. It's that old canary in a coal mine that if a canary didn't survive a coal mine, it wasn't safe for humans to be there. So CO2 is kind of a matrix we use for measuring air quality. And then how this ties back to COVID, during the last major pandemic the Spanish flu back in 1918, it lasted a couple years, and in one of the British medical journals, it was taught one of the ways to combat influenza was to breathe cool, fresh air and sleep out in the open. They noticed back then that with hospitals being overrun and setting up tents outside to treat patients, that the patients that were treated outside with fresh air recovered significantly better. And even the sailors that were coming back from the war back in 1919, they noticed that the sailors that were in the ships in the lowest portions of the ship, the lower sections that had poor ventilation, were the sickest of all of the sailors that were being treated. So it was recognized back even in the first pandemic that ventilation was important in helping reduce transmission rates and make people healthy. Ventilation has changed throughout the years, and in 1981, because back in the 70s, we had a lot of we had the energy crisis. So in the 70s, we started reducing transmission rates, and then in 1981, they reduced them all the way down to 10 CFM per person, which is where sick building syndrome started, and it was changed later on, and we'll kind of talk about that in a second. The next slide. So here's kind of the history of ventilation rates throughout the years. So as you can see, in the late 1800s, it was common to have 30 CFM of fresh air per person. And that ran all the way through the mid 1900s. That was a standard that we provided, 30 CFM of fresh air per person to keep people healthy and keep from spreading disease. And then in mid 30s, it changed to 15 CFM. And it ran 15 CFM for quite some time. And then, like I mentioned earlier, during the energy crisis, they changed it to 10 CFM to help save energy. But then we had a rash of sick building syndrome, a lot of people getting sick, so they increased it back to 15 CFM per person in the late 80s. And today it's still about 15 CFM per person to today's standard, which it's a standard set by ASHRAE. So how does all tie back to COVID? So this pyramid, upside pyramid, is kind of the process for helping reduce transmission rates in commercial buildings. So by increasing ventilation, increasing filtration are the two main ways to help slow the transmission down in commercial buildings. And if you don't have a good filtration or ventilation, you can supplement with some portable air cleaners, but that's kind of a last resort. And by no means does ventilation or filtration substitute for not wearing a mask. We should always wear our masks when we're around each other. But good ventilation is not a substitute for not wearing your mask, though. So a couple of things to think about. Some of the recommendations coming from the CDC and ASHRAE are physical distancing. So when you look at physical distancing, let's say, for example, a classroom that has, say, 30 kids, it's 1,000 square feet. And because of the new physical distancing requirements, we're not gonna be able to put as many people in a building or an office space that we used to because we have to keep people separate from one another. So anytime you reduce the load, for example, in a classroom where you reduce from 30 students to 15, if everything's working like it's supposed to, you've essentially doubled the ventilation rate and kind of met the guidance coming from the CDC and ASHRAE as when it relates to increasing ventilation by cutting your load in half. The only downside to this approach is you have to be really careful to make sure that your system is providing the minimum air, the outside air. OSA is outside air. So first you have to test your system, make sure it's providing plenty of outside air. And if you cut your load, your occupancy down, you'll get increased ventilation just by cutting your occupancy load. So what is outdoor air exchange? So in a typical building, especially in office spaces, the outside air is exchanged 6 to 8 times per hour. So we're piping in outside air and flushing out the interior air. Typically 6 to 8 times per hour. And it's usually done through mechanical ventilation through your HVAC system. It helps to have open windows and doors, but the primary means of removing stale air is through a mechanical ventilation through your HVAC system. And some of the ways to help is to create a plan to move as much air as you can to the space from indoor to outside. So how does fresh air get into a building to begin with? So this is kind of a diagram of a typical HVAC unit that sits on top of a commercial building on the roof. And most of those package units have a little door on the outside of them, typically an economizer. And that economizer is what brings in fresh air. And so it allows fresh air to come in. It mixes with outgoing air, and then it exhausts the difference out. So you can see fresh air coming in, it mixes with return air, and then the air goes out. And so it does an exchange rate about 6 to 8 times per hour in a typical commercial building. And so some of the naturally vented buildings work a little bit differently, but for the most part, probably 90% of the buildings out there, your typical package unit that's on your roof is what removes and supplies fresh air. So there's a lot of questions and concerns around portable fans and using portable fans to help improve ventilation. And they work. You just have to be really careful if you're using portable fans that you're using them to blow away from people. You don't want fans pointed at occupants. You want the fan in the door blowing the air outside, not towards people. And we'll get a little more into that later, but you want to position the fans near a door or window, and you want them to blowing out, not towards the occupants. You don't want to take any of the aerosols from COVID that we're breathing out and then blowing them towards people. You want them to blow away. So some of the upgrades that we'll get into with upgrades to your HVAC system are primarily filter related, and then making sure that you have the highest quality filter you possibly can. If you can increase the outside air, or readjust it through your dampers. And then there's some recommendation of keeping humidity between 40 and 60%. That's more on a national level. Here in California, we don't have a lot of issues with humidity. Right now, it's really dry. Our HVAC systems in California are not really designed to introduce more humidity. And this time of the year, it's usually some of the driest times for us. Um, but in other parts of the country, humidity is a major problem, and they have within their HVAC systems ways to mitigate humidity. We not so much here, and we'll get more into the filtration in a minute. So MERV 13 filters it's kind of what the standard that's been set by UC Davis and some of the other experts that I consult with quite a bit on the filter that we can use in our typical system. A MERV 13 filter will remove 90% of the particles in the air. And it'll operate in most of your mechanical systems. There's only a few cases around that some of the older systems won't be able to tolerate MERV 13, but for the most part, 95 to 98% of systems will be able to tolerate a MERV 13 filter. And then so they remove about 90% of the particles in the air. Even though a COVID-19 virus is really small, they have to piggyback on an aerosol or the dust particles that you see floating in the air. I don't know if you've ever seen the dust particles in the sunlight floating around. Well, when you're breathing, some people's lungs will take the moisture from the lungs, and the virus will piggyback on that moisture in an aerosol, just like an aerosol can. And it's that floating aerosol that piggybacks along with the dust particles that spreads around the room. And the MERV 13 filter captures about 90% of those particles and those aerosols. It's not 100%. It's not as good as a HEPA, but at 90%, it's really good, and it'll significantly reduce transmission rates by having a MERV 13. So what's the difference between a MERV 13 and a MERV 8? So in the picture here, you see a MERV 8 on the left here. It has roughly 12 to 13 pleats in it. And then the MERV 13 has usually 24 to 26 pleats. So there's twice as much surface area for capturing particles. Because the MERV 13 filters out much smaller particles in the air, it requires a much larger surface area to be able to handle the airflow. So you can buy good quality MERV 13 filters that will actually have a lower pressure drop than some of the cheaper MERV 8s. So it doesn't really impact your equipment as much as some people are concerned with. So here's a kind of a chart based on manufacturer. This is from UC Davis. And you can see that some of the better brands, 3M makes a MERV 13 filter that has a lower pressure drop than some of the MERV 7s. So if you, like I mentioned, if you buy a good quality MERV 13 filter, it won't really impact your equipment. It should function as designed. The only caveat is you have to change these things every 90 days. You have to be a little more diligent with doing your PMs because they capture a lot more material. You have to really be on your maintenance because if you ignore them, they can become problematic. So update your HVAC system. So you want to increase airflow as much as possible by first and foremost by looking at your load, your occupancy loads. That's one way to increase airflow and supply. Second, keep on your maintenance. You want to make sure that you're doing your maintenance regularly, changing your filters every 90 days, and checking your laundry rooms, your kitchens. Those all have fans. Most of the smaller ones exhaust. You really want to check on that equipment, make sure it's functioning like it's supposed to. And then you kind of want to monitor that regularly. We use CO2 monitoring, and we'll get more into the CO2 monitoring as a way to validate the performance of your equipment. But these are a couple of things you can do right away that don't cost a lot of money to look at your ventilation system currently. So one of the ways we're doing it at some of the schools, which is recommended by UC Davis and the Energy Commission, is to verify through a commissioning agent or a testing company that your system functions as it was designed. Most systems that are installed, especially in commercial buildings, that go through the permit process, all have to meet Title 24 requirements, and Title 24 requires all buildings to vent. Green buildings typically vent more than regular buildings. But if it's a building built through the permit process, when it was built, it did have a ventilation designed into it. And you want to be able to go through it and validate that it's working as it was designed. And one of the other ways we do is we also monitor CO2. And CO2 helps us validate the performance of that equipment. If we're seeing high CO2 levels in the building, we know it's not venting like it's supposed to. So CO2 has become kind of the canary in the coal mine, as I mentioned, as a way to validate that your building is being ventilated properly. And so back to the portable air cleaners. The best ones are commonly called HEPA filters. I do have some concerns with the HEPA filters. They're not a substitute for good ventilation. They do work. They are effective at removing much smaller particles and removing virus, but they're not a substitute for ventilation. They can be expensive, and if you're on a limited budget and you really want to improve the performance of your building and reduce rates, good ventilation is in my opinion more helpful than a portable HEPA filter, especially if they're not sized correctly. And then so there are also other recommendations coming out with ozone generators and electric static filters. I'm not a big fan of them. Again, as I mentioned, if you're going to invest in some of these devices, they can be quite expensive, and they're not a substitute for good ventilation. And good ventilation will help you in the long term with the health and safety of all your employees and staff and coworkers. Having good air quality long term is better than just right now trying to put a Band-Aid on poor ventilation with a HEPA filter. So there are multiple types of air cleaners out there. The ones that we're getting a lot of pushback are the ozone generating filters. If those things aren't watched carefully and you have poor ventilation, you're actually increasing the ozone to dangerous levels in your space. So you're gonna have to be careful with some of the ozone generating ozone generators out there as a means to help combat COVID. Because if they're not watched carefully, they can be more problematic and cause more issues than they help. So those are one of the things I would discourage anybody from using them is first invest your resources into good ventilation and good mechanical operating systems rather than investing in some of these ozone generators. And then when you're looking at portable air cleaners, if you have no other choice but to buy a portable HEPA filter, you really want to buy one that's sized adequately for your space. The little ones you see in most stores don't quite have the capacity to filter and move the air through your space. In order for some of these air cleaners to be effective, the air has to go through them fast enough to be able to be effective. If they're too small and the air isn't moving quickly enough through them, you're really not breathing filtered air. You're exposing yourself to unhealthy levels. So you really have to size these according. And some of the larger ones that are more effective can be loud. We have experience with other schools that have bought quite a few of these large units, and they're quite loud. So you kind of, like I mentioned, they're not a replacement for good ventilation. But if you have no other choice, they can work. You just have to size them correctly. And some of the other considerations, if you don't have the internal forces to help with the assessments and the maintenance, consult with an HVAC expert or a consultant that can help you. And look at fans as a way to move air around the room. And then just like to recommend the outside, if you can work outside if you can. Open up as many doors and windows as you can just to keep air moving. If you can get a cross breeze, it's better. But if you don't have any of these things, filtration is kind of your last option. But these are a couple of things to consider. And then we're going to go through a couple of scenarios. These are three scenarios of the three questions that I get asked most often. And so I put these together for another webinar I did for the Santa Clara County Health Department. So that's number two. Where's my number one? Scenario number one is each office or classroom has its own heating and cooling system. what is the most economical way to improve air quality? Well, first and foremost, we want to test and validate the performance, making sure that it is bringing in outside air. You want to install a MERV 13 filter, and then you want to install a CO2 monitor that helps you validate that the fresh air is coming in while the space is occupied. And I'll give you an example. We've been testing for COVID at quite a few of the schools, and we've had up to 900 people a day come through some of the buildings that are being used for COVID testing. And I monitor the CO2 level in those spaces, and we're averaging about 600 parts per million, which is really low compared to the minimum of 1100. It's fairly low, and we haven't had any reported cases of any reported cases of anybody catching COVID in those spaces, even though we have a lot of people coming through. And then one of the things to look at also is in some of the older buildings that have manual thermostats, most of the fresh air intakes require the HVAC fan to be operating at all times. So in Title 24, that fan should be running not the heating and cooling, the thermal component to the HVAC, but the fan itself should be running the entire time that the space is occupied, because that's how fresh air gets in, is with that fan running. Somehow my slides got switched around. We'll have to go back. This is scenario number 3. You're in an office or a classroom that has no operable windows or doors, or the doors open to the hallway. How can you maintain a good air quality when you have no way to open a window or a door? Same as the first one, you want to test your ventilation system, make sure it's operating, make sure that there's the required amount of fresh air is coming in the space. You've added the MERV 13 filter. You have CO2 monitoring, and you're keeping the fan running. Just like in the first scenario, it's one of the best ways to deal with those spaces. Let me see if I can go back. Okay. Okay, here we go. This was supposed to be number 1. So the weather's changing and it's getting cold. And now because it's getting cold, people want to keep the doors closed because it is getting colder and it's difficult to maintain temperature in that space. And it can be difficult to work if you're really cold. So just like the first other scenarios, we want to test and repair and make sure that the ventilation is working. We want to install the MERV 13 filter, and we want to monitor CO2 levels. And that should keep people relatively safe. But these are the 3 most common questions I get. And so some of the guidance that I spoke of today comes from ASHRAE. And if you're interested in going to their website, you can actually read a lot of their material. Their guidance is quite long. I summarize it the best I could into digestible slides, but it can be pretty intense, very technical. But you're more than welcome to go out there and kind of read on some of the material yourself if you'd like to. So CO2 in itself is also in itself can be create some health concerns. High concentrations of CO2 are also unhealthy, even though CO2 itself is a non-toxic gas. But in spaces, especially classrooms or really dense office spaces where there's a lot of people, it can build up in higher concentrations where it does affect people's health. In a book I just finished reading called Healthy Buildings, in the first chapter, the author talks about how a building manager has a bigger impact on your health and well-being than your physician does. And that kind of took me back to think that your building manager has a bigger impact on my health than a physician does. So there's something for everybody to think about. So, what is CO2? We all exhale CO2. It's carbon dioxide. We exhale about 2.3 pounds of it a day. And because we exhale so much of it, having a good CO2 meter allows us to look at that as a matrix, as a way to validate a building's getting enough ventilation. Because if we're breathing out quite a bit of carbon dioxide and it's building up a room, that's an indicator that there's not enough ventilation. And so CO2 monitoring is something that I've adopted over the past 2 years. I now have well over 1,000 CO2 monitors throughout Eastside, in almost every classroom. They're inexpensive. They're really easy to maintain, and they can provide a ton of information. And technology has gotten so cheap now that they're anywhere between 150 to 200 bucks for entry level CO2 monitor. You can buy handhelds now. You can buy desktops. They're relatively inexpensive. They have complete monitoring systems on the market today that you can monitor large campuses with them, and then you can get alerts. So there's quite a bit out there on CO2 monitoring, but it is a really good means to validate whether your building's getting enough ventilation. And so there are some other resources available through the Santa Clara County website. There's also a white paper I put together with a cover of high performing schools. We put a white paper together on ventilation and its effects on its occupants. You're more than welcome to read it. I have a website called WeNeedFreshAir.com where I keep a lot of the research available. If anybody wants to go take a look at it, it's WeNeedFreshAir.com. And also here's a link to a YouTube video I put together with one of my contractors on how to install a MERV 13 filter. There's in the school world, there was a lot of concern over MERV 13 filters, so we put together this quick video how to do a quick PM, preventive maintenance, and install a MERV 13 filter on a typical package unit if anybody's interested in taking a peek at that. And so I'll end it here with questions. If Hannah would like to go through the questions, we can answer more. If you have any questions that are not in the chat box, we can also answer them through the audio if you'd like.
So Carol was having some computer issues, but she did have a question, kind of, I guess, I feel like it's a little bit related to what you touched upon with the cold air, but she said, how do the systems work when outside air quality is too poor to be usable, for example, during the fires in the summer?
Yeah, so that came up quite a bit because of the fire. So unfortunately, there's both present a certain amount of risk. And so because there's a higher, that was just my opinion and the decision that we made as a district, that the COVID risk pose a lower risk than, COVID presented a higher risk than the particulate matter coming from the smoke. And since we already were wearing masks, we increased the masks from typical surgical masks to the N95s for anybody working outside or exposed to the smoke. So that was what the strategy we used, because I wasn't ready to turn off all the ventilation and increase the risk of COVID transmission with the smoke. So it was kind of a decision we had to make. There is some research coming out of UC Davis, and we're right now going to be testing in January a unit that has filtration and controls in it that will automatically shut the outside air and filter it during periods of fires. So we're going to be testing, UC Davis and I are going to be testing a system out come January that does that, but they're not quite yet available on the market, but we're testing them out. I know with the newer restrictions coming down the pipeline from the state, because of the surge, it's going to probably be more critical now than ever. They're already starting to put restrictions in stores. For example, 10% of the occupancy rate in most stores except for grocery stores. So as the surge continues, they're going to put more and more restrictions in place. That's just the direction I think we're going. So it is now more critical. If anybody has questions, they can reach out to me personally. My email address is on the first slide. I can answer questions. If you go to my website, there's a contact page. You can go there. I also have a network of commissioning agents and testing facilities that will test your equipment and certify that it is functioning. So if you need any recommendations, I can provide those to anybody. I have those available. I can email it. So don't be shy. Just reach out to me and I can send you information.
Great. Well, if no one has any other questions, I think we can hop off a little bit early. And yeah, feel free to reach out to Roger. Thank you so much for putting this on and presenting all of that.
You're welcome. Anytime. Like I mentioned, don't be shy. My email address is there. But this has become my wife considers an obsession, air quality. that I've been doing this for a couple of years. It just so happens that with COVID, things got expedited. You know, in the school world, we were able to get a bill passed that'll provide $600 million of funding for schools because of poor ventilation in schools. So 50% of classrooms have poor air quality. So we're able to get a bill passed, recently signed by the governor, that'll provide funding for schools to improve ventilation. It's something I've been working on for a couple of years, and with COVID, that got expedited and sent forward, which was good. I it's just ventilation is not new. It's not a new subject. It just hasn't really been addressed well. In commercial buildings, you can increase productivity by as much as 10%. So if you're looking for a way in a commercial building to increase productivity, is monitor your air quality, monitor your CO2 levels, because it does improve people's productivity by 10%. Having that additional fresh air, because besides the crisis with COVID, fresh air is critical in people's productivity and wellness and well-being. We're spending 90% of our time now indoors, so it's more important, as much time we spend indoors, to have good quality air that we're breathing every day.
Great. Anything else you want to touch on, Roger?
No, that's it for me. If anybody has any questions, I'm available. No, thank you everybody for attending. Appreciate you devoting your morning to this. It's something that's near and dear to my heart. I do quite a bit. I'm right now going to be redoing my website. I've been featured on NBC News, Yahoo News, Business Insider has done an article on me. Blueprint Magazine is doing a piece on me, and we're actually going to build a complete new website. Mine is it's informative but not very user friendly, so I'm in the process of redesigning a whole new website that'll be a lot more engaging than the current one. That'll come out in February. So if anybody has any questions, it'll be the same URL, but it'll be completely revamped come January.